Hi, and welcome to the third part in these video tutorials where we're looking at PySpark streaming and how to customize that with the applyInPandasWithState functionality. In the previous two videos, we looked at an introduction and background to PySpark streaming and a little bit of information on the applyInPandasWithState. And then in the second video, we looked at how to set up a streaming source of data where we constructed a series of CSV files that would stream into a folder that represent information coming from flight data that we've recorded from aircraft. In this video, we're going to take a deep dive into the applyInPandasWithState functionality, and we're going to go through a fully worked example of how to write code using the applyInPandasWithState function. There is a notebook that accompanies this series, and you can download that from the website, which is www.padsresearch.co.uk, and I'll put a link to that in the description below this video. If you are interested in videos on data engineering, AI, maths and physics, then please subscribe and you'll find lots of how-to videos like this. So let's look at how data will flow through the notebook that we're just about to look at. So we're going to start by receiving data from a streaming source, and this is going to be our data set that we set up in the previous video where we were streaming CSV files into a folder that contained records of our flight data, so things like the engine vibration, etc. We're then going to group that data, so we're going to group it by the flight ID. So each flight, so let's say we have a 2-hour flight between London and Spain, then all the data points on that flight will be grouped into one group. When we receive that data in our streamed batch, we're going to be calling a function called updateState, and this function we're going to write ourselves, and this is going to manage what we store in our state, whether we aggregate the new data that's come in or whether we customize a particular structure that we want to develop ourselves, as long as it fits in within a tuple. And then once we've combined all that data together, so the new stream data plus the existing state, then we're going to upsert that data into our destination, which will be a delta table, and we'll use the for each batch functionality to do that. So that means we can continuously update our delta table with the current state, but we don't have to remove that data from our state in order to write it to the table. So the bulk of the work will be around writing the updateState function. So let's have a look at the flow of that. When we write our updateState function, that's going to receive a few parameters. That will include a group key, that is the ID of our group, and then we're going to receive an iterator that will contain a collection of pandas data frames, and each of those pandas data frames will contain all the data for a particular group that we're interested in. And then finally we're going to receive the current group state, so that will contain the tuple that we want to update. Once we have received that data, the first thing we're going to do is to check to see if the group has timed out or not. So for example, if we set our group to time out after 5 hours because all our flights are only lasting 2 hours, then we'll check to see if that timeout has happened. If it has, then we would get rid of the group. So if that state has timed out, then we're going to go and grab that final tuple out of the group state, and we're going to output those results to our delta table, and then we're going to remove or delete that group state from memory so we don't keep building up a larger and larger set of data in our group state. Once we've established that the group state is not timed out, then the next thing we're going to do is check to see if the group state already exists or not. If the group state does exist, then we're going to get the existing data in that group state and combine it with the new data that's been streamed in our batch. We'll then output that data back to our calling function. And we'll also check to see if the group state has been finalized in that circumstance. If it has been, so i.e. we get a bit of information that says, okay, now the flight has landed, then we will finalize that information and we will remove the data from the group state. If the group state does not exist yet, i.e. it's the first time we receive a set of data for that group, that might be, for example, when the plane first starts up and is about to take off, then we will initialize the group state with the new data that we've just received from our pandas data frame. So that's the process of how we will update our state. It's a bit convoluted, so you may need to come back and watch this section again a couple of times, but let's now jump in and have a look at how we're going to code this. Okay, so here is our notebook where we're going to use the applyInPandasWithState function in order to customize our streaming. So let's start to have a look through this. So first of all, we're going to test our functions with PyTest, and because it's in a notebook, we also need to use IPyTest. And then we do our standard imports. We're going to work with pandas, so we need to import pandas. We have the standard PySpark imports, and we're going to import delta tables. And the additional thing that we're going to import here is the PySpark.sql.streaming.state, and we're going to import the group state and the group state timeout object, and we're going to use those later in the code. So everything else here is fairly standard apart from the group state and group state's timeout, which is specific to what we're doing in this notebook. Let's scroll down a bit. So we're going to call the autoconfig option for the IPyTest just to get things configured for us to running testing. And we're also going to do some optimizations. So we're going to use the rocksdb in order to store our state. And that will operate much, much faster than using the out-of-the-box PySpark state management functionality. So when we have got really large sets of data, and in the real example there were huge amounts of data, then rocksdb is a much better option to manage our state. So we can put lots of data in that, and that will be reasonably performant. We're then going to set our global variables. So this is things like specifying where our volumes are. Again, in your environment, you're going to need to change these. You're going to need to point it to where your actual catalog is and where your schema and volume names are, etc. So please do configure that to point to your own environment. And we're specifying things like, okay, where is our streaming data and where are we going to checkpoint our data? So if something goes wrong in the middle of the process, then we can fall back to this checkpoint location because all of this is going to be stored in memory. Let's scroll down a bit. Now, in our applyInPandasWithState functionality, we basically need three things. We need to specify what is the structure of the data coming in. So here's our streaming data that we're going to receive from the aircraft. I've called it Internet of Things. So we're going to get a flight ID, all of the various different measurements that we're taking, the date, time, and whether or not the aircraft has landed. So that'll be the structure of the data that's streaming into our datasets. We then also need to specify what the structure of our state is going to be. And remember, this is converted into a tuple. So for our example, we really want to store all the data in the state because the original idea of this was that an AI algorithm would be analyzing that data to make predictions about issues that might be coming up. So here we're basically storing an array of all of the different fields that are coming into our data. So we've got an array type, and then within that array, each item picks up this data IoT schema, which is this thing here. And then finally, we need to output the data. So we want to store this in a delta table. And this is the structure of what we're going to store in the delta table. So we're going to take the flight ID, and then again, we're going to take an array of all the readings which were taken for that flight. And because this is just a demo, we're going to take two parameters here. We're going to say, did the engine vibration test pass for the left and right engine? And that would enable our engineering teams, for example, to run a report to know that they need to have an inspection when the aircraft lands, and to report directly back to the pilots to let them know that there's an issue. Then I've also added in this state status thing, so that's useful for putting in any errors or any other information that we want to put into the data that can let us know what's going on with the state, because it's a little bit hard to debug with this. So I've built in some error handling and some debugging options that make our life a little bit easier. So let's jump to the starting point of this code, which will be to stream our data. And that starts here. So in the previous video, we created a streaming set of data which was regularly writing CSV files into a folder. And now we're going to pick those up. So we're going to do spark.readStream. We're going to specify the schema of what we're reading, and we want to read CSV files from this volume. So every time we get a new CSV, that's going to stream that data into this data frame. And this is our starting point of this process. Once we've got our stream source data frame set up, then we want to start to customize how we're dealing with that stream. So the first thing we want to do is to group the data. We want to group our data by the flight ID. So when an aircraft takes off, it will give a number of readings, and then when it lands, we will conclude that group. So everything, all the readings that we take within that flight period, we will group together. And then when the aircraft goes on its next flight, again, that'll be a new group. And this is where we customize how we deal with this streaming. So now we say we want to use the applyInPandasWithState. And we've got a few options that we can take here. So we've got the function that we want to run. So this is the function that's going to manage our state for us. And we're going to custom write this, although generally it does follow a similar pattern in how you would code that function. We want to specify the output struct type. So we looked at that a minute ago. And that's going to be the structure of data that ends back in this result data frame. We want to specify what the structure of our state is. And remember, that's going to be stored as a tuple, although what we're actually passing is a struct type. We then have this option here, which is kind of a bit pointless in this situation because really the output mode is controlled by the update state function. And we specify whether we want this to time out or not. So we might want to specify that this times out after 2 hours, for example. But in this case, we're managing the state by looking at when the aircraft lands. So once the aircraft has landed, then we see a marker and we get rid of the state. But we could also add a catch-all which says, okay, just time it out after 5 hours. So, if the transponder stopped working or there was some loss of signal or something, then just time it out and don't hold the state indefinitely. So this will call this function updateState in order to manage what's in our state. So let's go and have a look at that function. Okay, so here is our updateState function. And the first thing it does is it takes a number of parameters from the calling function. We're going to take the ID of the group, and that's going to be a tuple. We're going to take a series of data frames for each group. So if we have 90 records in our batch, and there are 3 different aircraft in the sky, then we would have 30 records in 3 different data frames. And this is a pandas data frame now. So now we've converted from a PySpark data frame into a pandas data frame. And then we're also going to receive this group state object. And that's physically going to contain our tuple that we want to update. So the tuple represents the state of our group. And we grab some of those values and initialize that here. Now, note here that we're grabbing the key and how you do that with a tuple. So because it's only got one value in it, we do need to have this extra comma here. So when I grab the key from this tuple object, it will put it into this int ID. But it's a little bit odd in the syntax in that where it's only got one item in it, we need to put this comma in to tell it that it is actually a tuple. So we've got our 3 sets of data. We've got our group ID, we've got some pandas data frames with the stream data in it, and we've got the group state. So the first thing we want to do is to check to see whether or not this group state has timed out. So if this is not the first time this function is running and the data is already in there, then we want to see if it's already timed out. So if it has timed out, then what we're going to do is pull everything out of that state. So this is going to read the tuple that we've stored in our state. And in our case, we're storing a list of all of the readings that have been transmitted by the aircraft. We want to do our final aggregations. So in our case, we're going to say, okay, were there any problems with the left or right engine vibrations, and has the plane landed? So that's the final state that we want to pull out. In the real world, what this was actually doing was running an AI process which would look to predict to see if there's any issues in the data. And then immediately report that back to operational teams. We update our status so we can see what happened in our data. So we just say, okay, this set of data is now timed out. And we create our final data set that we want to return to our delta table. So you can see this grabs the values of whatever we aggregated, puts it into a data structure, and then outputs that as a data frame. And that's what gets returned to our function that we just looked at a second ago. And then finally, because this state is timed out, we need to remove it. So we don't want the state to get bigger and bigger and bigger. We want to keep it as efficient as possible. So once we no longer need the data and we've written it out to our delta table, then we can remove this information from the state. Now, if the state is not timed out, then we go to the else tract instead. So the first thing we do is to check to see if this state exists or not. So is this the first time that we're writing data out for this group, or does it already exist? Is this just subsequent write from extra stream data? So if the state does already exist, then what we need to do is to get the state that's already there. And remember, this is a tuple. So this gets whatever we've stored in our tuple from the group state. And because we're just simply storing a list of data, it just adds the list of data stored in the tuple to our new data that we've just received, and then recombines that back into a tuple and updates our state with the new tuple. So this tuple now combines our existing data with the new data that we've just received. I'm now going to aggregate all of that data as one set and apply my AI algorithm or anything else or any other checks that I want to do in order to understand whether that complete set of data is going to cause an issue or not. So I run my checks to see if there's any problems with the right or left engines and to see whether it is landed or not. In your version, you might want to swap this around. You might want to do the aggregations first and then store that in the tuple, and that might be slightly more common. We're going to give an update status to help us with our debugging. So this will say, okay, this part of our code ran, so we did a state group was updated. And then again, we want to output a set of data. So this is what we're going to output. We're going to output a flight ID, all the readings that we've currently got on our tuple, whether there's any issues with the left or right engine. We're going to put that into a pandas data frame, and that is what is going to get returned. And then we'll check to see whether the flight has landed or not. If it has landed and this was the last set of data that we want to read, then we're going to remove that set of data from the state so that we don't have larger sets of data in our state than we need to. If this is a new state, so it doesn't already exist, then we go down a different path here. So this time, rather than combining the tuple with existing data, we need to initialize it. So we get our list of readings that we received, and we put that into a new tuple. And we're simply going to update this state with that new tuple because there's nothing already there. So we can just put the new data in there. We again analyze that set of data. So we want to understand whether there was any issues with the left or right engines and whether the aircraft has landed or not. Again, you might want to do this the other way around if you want to aggregate the data before you put it into the state. We do some reporting to say what's happened. So we say, okay, the state group initiated, so we know where we've got to in the code. We again create a data dictionary that we're going to put into a pandas data frame, and this will be what we return. And again, we check to see if the aircraft has landed. If it has, then we remove the state because we don't want to have additional data in the state hanging around. So we're basically following the same pattern. We are looking in our existing group state to see if there's any data in there. If there is, we combine that with the new data. We do some kind of aggregation or AI analysis on the data. We update our state with either our full list of data or with the results of that aggregation. We create a set of data that we want to output, so this is the data that we want to write to our delta table, and we return that data set. And finally, we do a check to see if the state needs to be removed or not. Now I've got all of this in a try-catch statement, so that was kind of useful during development. And if there were any errors that occurred during this process while I was writing it, then I could pick up that error and write that back to the data output. And that just made my debugging a lot easier. And you can see that we're now yielding that data frame output. So each of these options, they all create a data frame output. So there's one there in the exception. There's one here in the initialization. There's one here where we're combining the existing data with the new data. And there's one here where the state has in fact timed out, and this is the final step for it. So whatever path this takes, it outputs this set of data to our calling function. So that data frame that is returned by this update state function will match the format of this output struct type, and it's going to end up in this result data frame. So now we need to do something with that result set. And what we want to do is write it to a delta table with an upsert. So let's have a look at how we do that. So the first thing we want to do is to create a delta table if it doesn't exist. So let's add that delta table here. And we want to optimize how we query that table. So we're going to turn on liquid clustering. And as well as just turning on liquid clustering, we're also going to optimize it. And now we've got a delta table where we can write data out to. We're going to upsert our data. So we're going to work with this result data set that we got up here. So this was the data that was returned by our update state function. And we're going to say, right, now we want to write that data. So we're going to write the stream. And how are we going to do that? Well, we're going to call the for each batch function to do that for us. We're going to make sure that we've got a checkpoint if something goes wrong in the process and we need to restart it. And then we're going to tell it to start. And that will kick off the whole chain of events. So when this runs, every time it receives a streamed batch of data, it's going to call this function here, batch insert. And this is going to receive our batch of data. So this is the same schema of data that we received in our result data frame. And it's going to pass that to a delta table where we're going to do an upsert using the merge function. So if it's new data, then we're going to do an insert. And if it's existing data, then we're going to do an update. And data will get updated every time we receive a new microbatch. And that means we can group and aggregate data, but always have it available in our delta table. And we don't have to wait until that group has finished, i.e. until the flight has landed, in order to get that data updated in our delta table. And that would be the case if you're using a standard append functionality. Now we can add a bit of testing with these functions. So because I've got all of this sat in a notebook, then we're going to use IPyTest. It might be a bit neater to separate this out, have it not as a notebook, have it as a Python file, and then we could test this separately just with the normal PyTest. But for the purposes of this demo, I've done it in this way. So here we're going to test one of our functions. We're going to test our convert pandas data frame to list function. And we're going to say, okay, I'm going to give you some data. I'm going to say what I expect that result to be when I get the response. And we're going to assert that the actual data matches what the expected result is. So we've got a couple of test functions there just to demonstrate it, but you can certainly add more test functions in for your own purposes. And I've got another one here. Okay, let's have a little look at the development process, because It is quite difficult to write this function because you basically need to have your stream running, because it's quite difficult to simulate passing this group state function. That means as you're writing this and you're getting errors, it's quite difficult to see what's going on. So I employed a few strategies. So the first thing I did was to output the status in the data I get back again. So I could actually output errors in the return data, and that was useful specifically for debugging this function. The other thing I did was I tried to pre-write sections of the code before it went into the streaming process. So I've got this section here called pre-update development testing, and before I added my code into the update state function, I'd test it out first by writing little snippets of the code. So here, for example, I have created an example tuple. So this is some data that I want to test. So I'm assuming this data is already in my state, and I'm putting that into a tuple and just printing it out so I can check what I've got. Here I want to simulate a streamed read. So rather than doing a stream read, I'm going to do just a normal read. So I'm going to do a one-off read of that CSV folder. And I'm going to test how my function convert pandas data frame to list works by passing it a set of data as a pandas object and check that I get this list out that I'm expecting. Then I can print that out to see if that's correct or not. Now I want to go the other direction. So this time I'm going to create a pandas data frame, and I want to check that this function is working okay. So check that I can convert the data frame back into a list again, and then again print that out. And then I'm going to check that my aggregation function is working. So I've now got a set of data I can use. So I've got this combined data where I'm combining the new data and the previous data and passing that to my analysis function, which could be AI or any other kind of function that you want to write. And I'm checking that that gives the expected results back out to my pass-fail for the left and right engine vibration test, and then printing the results of that out. So by doing some of this coding first before I put it into this update state function, so for example, you can see I'm testing that line here, and I've got that line down here as well. That's making it a bit easier for me in the development process to understand what's going on, rather than getting stuck in the depths of the update state function and the difficulties in bringing back some of that error reporting. So once I'd got all this functional and I got it doing exactly what I wanted to do and what I was expecting, I then copied this code into the update state function, and I used the state status to do any further reporting as to any other errors or issues that had occurred in this function. And because this function runs in a worker node, then to get any errors out of this, you sort of need to delve through the UI in Databricks to find those errors, and sometimes that can be a bit of a pain. So that is the applyInPandasWithState function and how you can customize it. I hope that you found that useful. If you've got any other views, then please do comment and let me know. And if you're interested in data engineering, AI, or maths or physics content, then please do subscribe and you'll find many more videos like this.